Let's look at how we can use StatCrunch to build a confidence interval for population proportion. Before we build the confidence interval for proportion, we'll first ask the question, what is the point estimate? The point estimate would be the number of successes, that would be 48, out of the 320 patients. And so we can do this on a calculator. To build the confidence interval for the proportion, we're going to use StatCrunch under Stat, Proportion Stats, One Sample, and we're going to do with summary. We don't have a data set here to work with. In this, we'll need to put in the number of successes. That would be 48. And the number of trials, that would be 320. We want to perform a confidence interval. At this point, we don't know what the confidence level is, so I'm just going to press compute. And the reason I'm doing this at this point is to show you that part of the output from the confidence interval is to give us what the sample proportion is. So our p hat here, the sample proportion, is 0.15. Again, I could have gotten that by just taking a calculator and dividing 48 by 320, but I did want to show you that StatCrunch will do that calculation for you as well. Before using the package on StatCrunch, you need to make sure that the conditions for using the normal model for the sampling distribution of p hat are satisfied. Primarily, the condition you need to be concerned about is if I take n times p hat times 1 minus p hat, is that going to be greater than or equal to 10? And so if we take on a calculator my n is 320, my p hat is 0.15, and if I take 1 minus 0.15, I'm going to get 0.85. That is equal to 40.8, which is greater than 10. The other condition that we should check is that the sample is less than 5% of the population. 320 is definitely less than any reasonable population we're going to be looking at, so that's not a problem. So yes, the conditions are met to satisfy building the confidence interval. Next, we're asked to construct a 99% confidence interval. So again, to build a confidence interval for proportion, we're going to go to Stat, down to Proportion Stats. We're going to find that this is the package we use for the next couple of chapters. If we're dealing with proportions, we have one sample, and we have the summary of the data. Our successes, again, are 48. The number of observations are 320. We are constructing a confidence interval, so I need to change that. My level of confidence, it is asking me for a 99%, so I need to change this to 0.99 from 0.95, and then press compute. My confidence interval is then given as the lower limit and upper limit listed on the printout. So my lower limit here to 3 decimal places would be 0.099 to 0.201. Last thing we're asked in this question is to interpret our confidence interval. when you're interpreting confidence intervals, there are three things that you are looking for in the wording. Number one, you are looking for the word confidence or confident. So A and B say we are 99% confident. That would be a correct interpretation. If it starts talking about chance or probability, that's a key that is wrong. Don't choose those. Next, we are looking that it says that the true proportion, in this case the true p-value, is contained in the interval. And so that would be 1, that we are 99% confident that the interval contains the true value of p.